Thank you so much for that amazing introduction. Yeah, today I'm going to talk about learning analytics, what it is and what its role in education is. But first I thought I'd tell you, like everyone else has, where Bergen is. Has anyone been to Bergen? Oh, a few, yeah. So we're in the southwest coast of Norway. We've got a UNESCO heritage site, these beautiful buildings, and we're the gateway to the fjords. It's a city that's very, lots of hills. We're surrounded by 7 hills, or mountains, they say. And we've got these beautiful old neighborhoods. But the one thing that we can claim is that we've got the world's largest gingerbread city every December. So if you want to come in the winter, you can come in December and you can imagine the smell. 2,500 houses are involved in this. And if you see in this one picture, someone even did a replica of the London Eye, and it actually moved around, so it was amazing. Okay, so I'm going to tell you a little bit about my center very shortly, and I'm going to introduce what learning analytics is. I'm going to use a state of the field report that we did. I'll tell you about a few of the projects that we have, and in that way you can get a feel for what it is, and then I'll tell you a little bit about what we've learned over the last 3 years. Okay, so SLATE, we're a center that was established by the Ministry of Education. They wanted to know more about this field of learning analytics, they wanted to know more about technology and learning, and they wanted to know more about adaptive learning. So we're a national research and competence center within the learning sciences. And the thing is that it's not just to do the research, it's also to raise the competence of others within the educational sector, which actually includes the edtech vendors as well. So we have some projects with them which are a bit interesting. And then we carry out research in areas like learning analytics, big and small data in education, adaptive learning, assessment for learning, innovation and creativity, and learning and technology, and all facets of human learning. So we have school projects, high school, university, workplace, and out of even cancer patients learning about handling their disease. We're a multidisciplinary center. That was one of the requirements of the government when they put out the bid for this center. So we have computer science and information science, educational science, psychology, cultural studies. So we're very mixed. So we do interdisciplinary work because we try to work together and take different perspectives together on different problems. And that's one of my things that I will say about learning analytics. We can't just let the computer scientists do it. And we're to also conduct research to advance the frontiers of the science of learning, but also as well inform education impact and policy. This is my center, quickly. So we are, we're just hiring a new professor, and we have 3 senior researchers and 6 PhD students. I've got 2 adjuncts. We have always a number of different master students coming in and out. And then we have a research foundation in Bergen. We work very closely with their big data center. And we have a number of faculty from the university. And we are administrated underneath the psychology faculty. Even though we're a national center, we're under psychology. The profile, we do learning analytics, creativity, learning and technology, assessment innovation, and theoretical pedagogy, and then emerging technologies and data. So even though we're learning analytics in focus, we're not just looking at data. We take a critical perspective on it as well. Last year we had about 30 projects, and it sounds like a lot, but all the PhD students, they're all working on 2 or 3 papers, and they all listed them each as an individual project. So suddenly we ended up like about 20 projects that are theirs, but we let them do that. And they're grouped. I know you can't read them, but they're sort of grouped in this area, with learning analytics being the most common set of projects. Last year, we also participated in the Innovating Pedagogy report, and we worked together with the Knowledge Center for Education on a systematic review on learning and technology, learning with technology in higher education. And then the big highlight last year was coming into the International Association for Educational Assessment conference, when they had a focus on big data And this was a new venue for us. None of us had ever published in this area or been to this conference before, and we had 6 papers there, and 3 of them were with our PhD students. It was very nice to come into that field and see how sort of the assessment field is working. Okay, so let's talk about learning analytics. Everybody stand up. Get you awake this morning. Okay, so I'm going to ask you a question, and if you answer yes, you can stay standing. If you answer no, you have to sit down, and we'll see how many are standing at the end. I have an idea, and let's see if it's correct. Have you heard of learning analytics before you read the title of this keynote? Okay, good. That's what I thought. Do you really know what learning analytics is? Okay, I didn't think so many would go down. Have you used a tool that collects student data on learning or assessment activities? Okay, good. Have you used a dashboard or visualizations that give you insight into your students' learning? So far, okay, a few more. Have you changed your teaching based on that insight? Oh, still a few. Okay, sort of what I expected, but now the last one. Has your workplace implemented learning analytics at an institutional-wide level? Maybe? Okay, who's left? Where are you from?
Indiana University.
Which one?
Indiana University.
Yes, okay. Okay, yeah, and you're from?
University of Australia, we're using information for quality assurance for our regulations and things like that.
Yeah, okay, so that, and there's no one from Purdue because they would also be standing here. Okay, so that sort of gives you an insight into some of the questions we could ask about learning analytics. So I guess I do have a little bit to tell you. We'll see, at least how we see the field. Okay, so the most common definition is from the first conference in 2011, as learning analytics is the measurement, collection, analysis, and reporting of data about learners and their contexts. So it's about the learners, but it's also about their learning environments. And we collect this data for purposes of understanding and optimizing learning and the environments in which it occurs. And again, it's about learning and about the environments. And I'll come back to that in a moment. This is a word cloud one of my students made from the LAC conference keywords. And the nice thing is that learning is big and in the center, and it's about mining, and it's about systems and data and students. It's about Bayesian, it's about intelligent, educational, it's about modeling, and things like that. And I think, in my interpretation of it, that it draws on fields. So learning analytics as a research field draws on the historical fields of educational data mining, AI in education, intelligent tutoring systems, which actually have been around since the 70s, so this is not something new. They have been doing, in my opinion, learning analytics since that time. The learning sciences, and sort of the big data and business models. So these are some of the fields that we draw on. And the field, as a research field, is called Learning Analytics and Knowledge, and they have their own series of conferences called LAC. This is a visualization of ISO's definition of what learning analytic is. So you have some kind of learning activity, you collect data about it, you have to store the data and process it, you have to analyze it, visualize it, and most importantly, have some kind of feedback action. So most of you sat down when I said, have you acted on the analytics that you've seen? Because that's really a hard part to do it. Each of these boxes in itself is, I would say, a research area. So how do we design learning activities, learning design? How do we collect the data? That's actually not so easy. Everybody says data is everywhere. That's not our experience. It's not only, sometimes it's really hard to get access to it. And sometimes it's not the data we actually want or the data we need. We have to process it and store it, so how are we going to keep access to these data? How can we have it stored in a way that we can actually run algorithms on it or process it in different ways? Then how are we going to analyze it, visualize it. Visualizations in itself, how do we make visualizations that are understandable and actionable? And then what kind of feedback actions can happen on those? So that is sort of, to me, sort of the general cycle. This is from UNESCO's brief on learning analytics in 2012. You can also think of learning analytics from the perspective of the data that can be collected at the micro level, interaction between students and a teacher or between students and a machine, at the meso level, at the classroom, interaction at the classroom level, or macro level at the institutional or even national level. And they propagate data from the micro level often up. And is that something we really want to do? Does something that's happening in the classroom really have something to tell us on the national level or not? So, but people do these kinds of questioning as to whether this data should move up and should it move down as well. This is an architecture that enables adaptive learning systems where you can use educational data mining and learning analytics. And I know you can't see it, but that's another take on learning analytics that you'll find from some people, interpreting it that way, that there needs to be, there's often some kind of external data sources being fed into some kind of decision making that's based on algorithms, and where you have collecting data as the student interacts with the system. Finally, I want to say you can also think of learning analytics from an architecture perspective. So we've heard someone mention JISC before. I think Sean mentioned it yesterday. But you can think of it as there's some kind of way to collect data. There's some kind of data and storage and analysis mechanisms. And then you give presentation and action out through other applications. Maybe give alert to students or to teachers, etc. So you can think about it on these challenges of architectures. And if you're thinking of implementing at the institutional level, you definitely have to think of these kinds of issues that way. A brief history of it as a research field. The Society for Learning Analytics Research, SOLAR, was started in 2011. The first conference was also held in 2011. The first, what they call flares, were held, so those are sort of national meeting places for learning analytics, were held in 2012. And they had the first SLAC Dataset Challenge, where they had data sets and asked everybody to analyze them and had a challenge around that. The first Learning Analytics Summer Institute was held in 2013. And if you want to learn and have a quick, pressured week in learning about learning analytics, I recommend these series. The journal came 2014. The first European project, the LACE project, was in 2014 as well. And they have a whole set of resources if you go to the LACE website. And in 2017, the first set of handbooks were published. They're available on the SOLAR website for free, so you can download them. And it's a good overview of different aspects of learning analytics. In the Nordic countries, we started in 2017 our own summer LASI. They have them in Spain and Australia. Germany had their first one last year. Other countries may be having them as well. But we decided to do it on a Nordic level, and this year we'll have it in Tallinn. So our third one will be in Tallinn this year. And that just gives people nationally or locally, regionally, that don't have the funds or ability to travel to the main LASI, the summer school, to go to that. Okay, so now we've been talking a little bit about data, and when we think about educational data, traditional education data, we have these kinds of data sets often: academic information or teacher-produced data, student-produced data, testing and assessment data, often demographic data or behavioral data. And those things are, if you read any kind of educational research, they often are referring to those. But what we see in learning analytics is new types of data. So we have clickstream, or what we call activity data, when they interact with computers, audio data often, video, facial expressions, eye tracking, biosensors, GPS or location data, air quality data some people are working with, fMRI data. We heard a little bit about this brain measurements yesterday, etc. And this means that we have to have some kind of multimodal way of dealing with all of this kind of data. So there's a whole subfield within learning analytics called multimodal learning analytics. And here the idea is to understand process data to understand learning. So it's not just a snapshot in time, we actually can follow interactions of students over time and try to understand that. And of course we did that before, but it was much more difficult to get the data. Here it's very nice when it's already digitalized, although it will give us a lot of problems, which I'll mention. When we look at what the roles of learning analytics are, we can think of who the stakeholders are for learning analytics. And of course, it can be students or teachers or instructors. It can be the institutions or their leaders, policymakers, and I mean a big part of the research is for the researchers as well. So we have to remember the researchers and a lot of the data are helping us better understand learning. The actions can be reflective or adaptive or predictive. They look for patterns, they look for insights into trends, informed feedback. They look for learning and learning trajectories. There's predictions, predicting dropouts, predicting students that might be about to fail or they're about to look at what successful students do. They look at actions for early intervention. So they want to intervene and stop people from dropping out maybe, or at least talk to them. Recommendations for learning and teaching actions, and maybe recommending pedagogical resources or new kinds of activities for students. So that's sort of a very sort of general overview of sort of the different kinds of things they try to do with learning analytics. And I always like to mention this because I think this is really important. Zach Stein went through all the articles published till 2014, and he found and he categorized learner-centric analytics versus learning-centric. And I think this is really important because the learner-centric are behaviors. What is the student doing? What are they clicking on? What are they watching? Are they attending class? Those kinds of behavior aspects. And that only maybe tells us something about engagement, but engagement doesn't necessarily mean learning either. So if we really want to get to learning, we need learning-centric analytics. And then we need to go into things like texts people are writing or things they've designed. We have to go into the artifacts or into the learning aspects of different processes, and that's much more difficult. So the majority of the work is done in the learning-centric area. And I think we need to move towards more learning-centric analytics, which is much more difficult. So now I'll give you examples from a State of the Field report that we did in 2017. Even though it's 2 years old, it's still or 2.5 years old, it's sort of, or a year and a half old, it sort of shows the trends of what was going on. We were really interested in people who had a pedagogical perspective on what they were doing. And the report's available on the Open Access Archive at my university if you're interested. And I won't go into the details of the searching or anything like that, I'll just show you some of the results. So we ended up with 100 papers in the end, and these are the categories where the majority of where the papers were, we categorized them. So some people are working on building algorithms or models that are used. Some are focused on data, just smack on the data and what kind of data are used. There were 9 papers actually addressing ethics, philosophy, and policy. There were some that were combining learning analytics with other things like either mobile learning or computer-supported collaborative learning. We put those into the LA Plus category. Some were very focused in writing about learning analytics for educators, some for learning analytics for institutions. And again, these are sort of the main focus of the paper. Of course, they cross over many of the others. There were 8 papers on network analysis. There was 1 overview paper that ended up in the system, and then 20 of the papers were predictive analytics or predictive analysis. And this is because some of the early days, they actually called a field partly academic analytics, and they were looking at these sort of institutional predictive dropouts and should we let people into the university, these kinds of things. Then there was 3 papers doing text analysis, which is, again, is not a new field, but they are now reframing it as learning analytics. 4 interested in tool development, and the rest were very focused on visualizations and aspects of visualizations. Okay, so this is a graph of the level of the papers. If you look at the pink area in the middle, that's higher education. So the majority of the papers are in higher education. This doesn't surprise me because I know that a lot of us do research on our own students or the data that we can easily get access to. So higher education. On the left, we have the primary, middle, and high school. And on the right, we have the MOOCs and workplace. So it's really, really focused on higher education at this point. Now there's more school-oriented work. This one shows us the number of data sets being used. In the first column, it is the log data. So 60 of the papers actually used log data, and of those, 12 only used log data. The second one to the right is performance data, so it might be your marks in a class or something like that. Then we have survey data or questionnaire data, 6 of the papers used, demographic data, test data, all the way up to learning design data. There was 4 papers that had learning design data. So it's a sort of variation on the different kind of data sets that are being used. This shows the number of students that were involved in the studies that are reported in the papers. And I think what's interesting here is that if you look, the median is around 100 to 500 students. So the number of students being involved in the studies tends to be higher than in traditional educational research. And there's even some 7 papers with over 50,000, and of course those would probably be the MOOC studies. So we're getting larger volumes of students that are being looked at. The learning analytics can be for different audiences, as I mentioned before. So here it is for the institutions is in the blue, for the educators is in the purpley one, on the bottom is for the learners, and the little one on the small other side is for the researchers. So it's sort of distributed mostly between the educators and the institutions, with a little bit of looking at should we be opening the learning analytics up to the students. This shows the different methods that are being used, and by far 43 of the 100 papers are just using plain statistics. So they're not doing anything more fancy than just statistics. Correlation analysis 36, and then regression analysis 24, and then we start to go up to the top of it, which you can't read them very well here. They're into machine learning and neural nets and things like that, but there's very few at that point that were really using those methods. This is showing the pedagogical approaches that were being used. The top one is computer-supported collaborative learning. Again, that doesn't surprise me if you know the field of educational technology, because that's a very big field, and they've been doing social network analysis, which is a method used in learning analytics for a long time. So you have a lot of those papers. And then for self-regulated learning, which was very nice to see, was the third one, and then down all the way to things like learning design and simulations and things like that. Again, these figures are all in the report. Okay, some examples from some of the papers. This is from Curtin University, and they do a lot of analytics and correlation studies between user actions and the final grades. So it's a predictive analytics where they're using sort of different data sets from the university, using library data and LMS data, etc., and they're predicting final grades. So that's very typical early days of academic or a field of learning analytics. This is also learning analytics. This is a system that doctors can use to learn to drill in bones. Has anyone tried one of these kind of systems? I've done one for dentists that do it. It's really amazing. You actually do get haptic feedback when you actually press on this button into the simulation. So this one is measuring how you hold the instrument, how hard you press, how you move it around, and giving you individualized feedback based on all the movements of this. Another paper is looking at dropout prediction. Again, as we remember, dropout prediction is quite prevalent in the early days. So this one is if you're female over 25 and married, or you're man and you're employed, or you're studying mathematics and you're over 25 years old, you're more likely to drop out. So, very interesting. But they were interested in getting feedback from this group on how they could make their education more flexible. Maybe they needed to have more longer time that you can take the course because maybe you can't be full-time, or maybe it should be in the evenings because a lot of people are employed. Okay, this is another very popular way to do it with the visualizations, is you have some kind of activity visualization of how active people have been in a learning environment or in a MOOC. So you would have, these are the same course, 2 different students. So you can see someone's pretty active throughout, and on the bottom, someone's not so active. And I just wanted to say, this is a paper that I was involved in 1999, and we won Outstanding Paper Award at EdMedia 2 years in a row for this study. And if you look at this, we were doing learning analytics even though we didn't know it in those days. So here we were looking at, we had a distributed learning environment, and we were looking at how often a team of students were involved, and my students were visualizing when the groups were together in the system. So I thought that was pretty funny. Here's some people who are looking at modeling emotion. On the left, they have an algorithm to identify when you're bored based on how you're interacting with an environment. And on the right, when you're frustrated. So obviously, there's differences in how you're acting with the system. Another very common thing to do especially within collaborative learning or any kind of network learning, is look at topics and participation. So on the left, we have topic modeling, which topics are most being discussed in a discussion forum. And on the right, on your right, there we have the involvement of the teacher, who in the middle first week is very central, moves a little bit out at week 3, and by week 10 is really out of the discussion. So those are very, again, have been being done by the CSCL community for a long time. This is a dashboard for instructors from the Open University, and it shows you information about the general trends in the class and about individual students at the bottom. It tells you whether they can predict what their final mark will be, etc. And they're in the advantage, and they do really great work in learning analytics because their data is all digital to start with, because they're an open and distance education university. So they've got a lot of very interesting dashboards. I will tell you, it will take you a few minutes to actually figure out what this dashboard tells you. So there is some kind of data literacy that's really needed here. This is some work we were doing ourselves. We were working with a fire brigade, and they wanted to have visualizations of the competences they have within their set of firefighters that they have. So we were working on different ways to visualize this kind of information. So you can see that this particular one can't do ship rescue. They're very good at traffic events, pollution rescue, hearthland fires. They have the expertise because this is the one fire brigade in Norway that actually can do them. There's only 2 in all of Europe. The other one's in Austria that can deal with hearth fires out in the meadows and things. They're very special fires, etc. So we have been working with them on different kinds of visualizations. Okay, so that's just sort of a flavor of some of the work that has been done. And when we analyzed this corpus of 100 papers, what we saw was that learning analytics is a very wide field. People are publishing in computer science, psychology, education. But we see that it's very data rich and theory poor. So there's not a lot of theory built into what's going on. And again, that's probably because the field is very new, and people already now are talking about how we bring theory into what we're doing. The majority of the early research has been in higher education, as you remember, the middle pink papers. Predictive analytics is very popular, usually used by higher education institutions for dropouts, retention, and curriculum issues. But predictive models and algorithms are situation dependent. And just because you make Indiana University makes predictive algorithm, it can't move to University of Bergen. So there's very little evidence on being able to move these predictive algorithms around. And if you think about it, it's really because they make it based on the data they have accessible. And it's maybe not the same as the data you have somewhere else. So this algorithm transferability is actually a big problem. And there's evidence of formal validations lacking, and this is what Rebecca Ferguson found in their report as well, which I'll mention again in a moment. So we also identified a number of gaps that we felt. So the application of learning analytics in the K-12, although there is one big project in the States, which I'll show you a book in a moment about. Research on everyday analytics. How do we get the data that's going on in a classroom? If we're only looking at what's happening in the digital tools, then we're really restricted in what we're actually looking at. So how do we get this everyday analytics? At that point, there was very little research on assessment and feedback. And again, as I mentioned, very few implementation studies, and this is, as Ferguson et al. 2016 find, there's a wide gap between the potentials identified in research and what's actually been implemented. And data literacy, there's a strong need for work here. We've worked in this area in a European project, and there's a very big interest. So not only do people now have to be digitally competent, they have to be data competent. And I've heard people mention this also the last couple of days. What does it mean to be data literate, and how much do you have to know about data, and what do you need to know about it, etc. And we need some social perspectives on it. Sean brought this up again yesterday, but what is all of this data doing about us? How can we reduce ourselves to just data, etc.? What are the impacts of it? And we have one project in this area as well. So what is the impact of someone collecting data about you? Does your employer then fire you as a teacher because you're not having your students pass the national exams, etc.? So we have to take these critical perspectives as well. So I recommend this report, Research Evidence on the Use of Learning Analytics from 2016, Rebecca Ferguson. It's available on the JISC website. Learning Analytics Goes to School is a very interesting book reflecting over why they failed. And it's not because of the technology or the analytics, it's actually because they failed to inform teachers and parents and sort of the more social aspects and implementation of that. But it's a very nice book. And then the Sheila report, if you're interested in implementation of learning analytics at institutions. It's a very nice European project that finished last year that gives a methodology about how to bring people, the right stakeholders within your institution together to talk about what you want to do with learning analytics, etc., because it's very, very complicated. We're talking about putting analytics into an existing IT system within a university, and we don't want to interrupt the day-to-day runnings of the IT, so the IT departments will be very skeptical to how we're going to introduce this learning analytics. And they've brought up many of these issues. Okay, so I thought I'd just in the end give some example projects that we're involved in. I have one student who's looking at learning analytic architectures. So if you're going to implement learning analytics within an institution or something, you have multiple data sets. And one of the biggest problems, not just in learning analytics, but also in big data, is the interoperability of this data. It's sort of a very computer science-oriented problem. So she's looking at technical and semantic interoperability and semantic technologies for how you can bring these data sets together. We have to use the data at the university. We're using the data at the University of Bergen, and of course we have the issues of getting consent from the students to do it. And I'll just tell you, without us even going any more than putting information on the web page that they can read, they have to read before they give consent, we have 73% of the students saying yes, that we can use their data. So we were quite surprised it was so high. Okay, we're looking at, one of our areas is sort of new technologies and what kind of data can we get out of it. So I have a PhD student who's looking at virtual learning environments, and what kind of data can we get out of that. So he's got a headset that combines eye tracking and VR together, so you can sort of get someone immersed in an environment, see where they're looking, but also he has these movement sensors within a room because people actually move when they're using VR, even though you don't need to. if you watch somebody in it, they're always physically moving as well. What are they doing? We've just finishing up a project, the report will come in August, where we've looked at the only tool that's being used in schools in Norway that has learning analytics. It's an adaptive learning environment for mathematics. This particular version is for middle school, probably 7th, 8th grade. And it's built by Gyllendal, which is one of the publishers in Norway, and it's called Multismart Øving. Now the interesting thing, it's built on a learning analytics platform that comes from Newton. Has anyone heard of Newton, any of the Americans? Yeah, so it's a company in the US. So all the data in Norway is going to the US. Gyllendal does not have access to their own students' data. Nobody can tell us what the algorithm Newton is using. I've even asked Ken Cottinger and my ITS friends in the States. Nobody has been able to find out what this is about. So that's one issue. So we've been looking at how this tool is being used in the classrooms. So just because we have a learning analytics tool, we need to know how is it being used. How are the teachers using it? What do the students think about it? We've looked at how the publisher promotes it, what they're saying. They've done a discourse analysis of the publisher's meaning about it, a master's project, just to look at this together. In the end, we will tell you it's a very nice practice environment. It replaces the practice book where they used to just sit down and write on it. On average, students do 200 tasks a week, which is quite amazing. They recommend themselves not to use it for more than 60 minutes a week. It's often used for homework. So that's sort of the main things we found about it. The interesting thing is one little boy went home and told his father on Friday, "Papa, the teacher was mad because I didn't do my 60 minutes this week." What do you think happened? Father's a lawyer. Father calls Gyllendal on Monday, starts yelling, "What data have you got on my child?" So it was very interesting. So they actually had to turn off the time tracking in the tool because of this parent was going to sue them. I don't know, we don't sue in Norway, but he at least put a question on it. But the interesting thing is for me is that we know time on task is important when you're learning mathematics or you're doing anything. And the father didn't seem to care that his kid hadn't done his homework. So it's sort of, you get these kinds of issues related to that. We have survey data and input from over 1,000 teachers, and it's being used in over 2,500 schools. So it's quite interesting. As a computer scientist, I have a question about these kinds of systems because it's supposed to be an adaptive learning system. So it's supposed to look at how, and in traditional work in intelligent tutoring systems, i.e. in education, you have a system build a model of you as an individual learner, uses that together with information about the domain, and tries to tailor tasks to you individually. This system is built on Newton, which is a recommender system, so it's using like Amazon type recommendations, and it's based on pure statistics. So is it really adaptive enough? Does it? Maybe in this case it is, but it may be for other learning situations, maybe not. So there's lots of very interesting questions around this. This is the project and the visualizations I was telling you, working with firefighters and healthcare leaders when they have sort of competence-based workplaces and they want to know what competences they have, etc. So we've done several different small projects with them. We have some projects looking at MOOC data. We have an Erasmus Plus project with 5 institutions, and then we have some other small projects in Norway where people are using edX. I have one PhD student who's looking at learning analytics and peer assessment. Has anyone used the tool called PeerGrade? Yeah, one person, okay. So we have all the PeerGrade data from 2015 to 2017, completely anonymized. It's 25 languages, it has multiple universities and high schools, over 10,000 unique student IDs, and over 6,000 unique course titles. And she's got this data set. What can she do with it? What can she find out? So she's been playing with machine learning algorithms, trying to understand things about feedback giving skills, learning design, and students' perception of feedback. Now, just having a data set, there's only so much you can actually do with it. In particular, this is a very good thing we've learned, is that it's not always the data we need to answer questions that we want. So the data that's saved here is decided by the developer of the tool. And David's he was a machine learning PhD student at Copenhagen Technical University. So he's a computer scientist and was just saving whatever data he thought he was saving. There's nothing in the data set that tells us which language it's in, doesn't tell us what grade level the students are, it doesn't tell us what subject they're in. So you have to do some kind of pre-analysis of the text to find out, is this English or not? A lot of the machine learning tools don't work on anything but English, so we had to throw out all the other languages, etc. So it was very, very interesting to work with such a data set. So she just finished the first studies there, and now in the second set of studies, what we're trying to do then is bring in more context information. So we need to have the context in which the data is collected and the learning is taking place. So here we're going to be looking at the rubrics that the teachers make that tell the students how to give feedback, and we're going to be looking at that. And we're also going to be using a learning design approach. Nancy Law at University of Hong Kong, Department of Education, has worked on a learning analytics design pattern language, and we're going to be applying that into this to try to give some kind of context to it. And she's going to be working with data sets from 2 different colleges in Norway around that, because then it makes it more meaningful when we can get the context data. And that is also a big criticism of the field, that the context data is often not there. We have another more critical project that's looking at something called intelligent accountability. So when you're looking at quality assurance projects, or quality assurance in different schools in different countries, you've got Chile on the one end, which is very test-oriented. If students fail tests, you're fired as a teacher. And on the other side, we've got the Nordic countries, which is very trust-oriented, and you have a different rhetoric around quality and quality assurance. So how is data figuring inside of these kinds of environments? So that's a more critical study, one of our PhD students. We're doing some work on teacher inquiry into student data and into student learning. So this is leftovers from a European project where we worked with a lot of teachers, and they will tell you that they are working with student data, they're just not doing it systematically. So we had 3 different groups of teachers draw how they work with student data on the left side, and we came up with a method that we're using to work with teachers in their way. We can't have teachers be scientists, we can help them be at least systematic and reflective about the different student data that they're doing. So we're working still with 2 or 3 schools in this area. We've just finished the first phase of a project. We've got funding for a second year, which to me is one of our most interesting projects, because it's a project with the municipality of Oslo, and it's funded by the Association of Municipalities in Norway. And they wanted a research partner in this project where they had this vision that any vendor who is delivering a tool to the schools in Oslo has to share their activity data. They can't just keep the data for themselves. Not only that, they have to share it with all the other vendors. So in this project, we've had 8 vendors, and we've worked with 5 different schools. We just delivered the report about 2 weeks ago, and we will continue the next project as well. So what we've actually, I'll come back to some issues here. So what we've done is actually built an infrastructure that allows secure exchange of data. We've gotten the vendors to put their data into the XAPI standard format, which has been chosen in Norway for educational data, and we actually got the vendors to do this. When we interview them, they say they did it because they're afraid to be locked out of the schools. We have a lot of things in place in Norway, being a small country. We have a FADA, which is the second level here. I don't know if this has a pointer. No, it doesn't seem to. I'm afraid to, I did something wrong. There, okay. I want to point at, just above the red box, we have a national login for all students, and both at high schools and schools. So you have a unique ID for all students, no matter what they're doing in the schools or universities. And we also have something called a data port, which is provided. It's like by Unit, which is our version of JISC in Norway, which allows for secure exchange of data. So we've built a hub then that is basically on top of these technologies, enabling us to see who can exchange and who can see what data. So teachers can see their own students' data, students can see their data, and a vendor can see another vendor's data about an individual student only if they have a task that is tagged to the same subject area and curriculum goal as the other vendors. So it's a very complicated, it's not so complicated, it's quite straightforward actually. So this has been tested and works, allows that. And then they want to know what is the achievement level of students in different areas of the curriculum, where should the teachers be focusing, etc. So we've done some background information on that. And interesting, and we did some interviews with the municipality, with teachers and vendors, and asked them their standpoints on learning analytics, on adaptive learning and differentiated teaching, because this is what they're interested in, on learning goals, student competence, learning outcomes, on assessment, and on sharing of data. And it's very interesting because they have very conflicting views on many things. And expectations are different, etc. And I think we need to be looking at these kinds of aspects as well. Okay, so what have we learned? Just to sum up. Okay, about data. It's about the access to the data. Do you have access to the data? Do you have access to the right data? University of Bergen, it took us over 9.5 months to get access to the data. The vice rector of education said we would have the data. It went down to, first I went to the IT department and I thought I could just say, can I have the Canvas data? No, that doesn't work. So the vice rector of education says yes. The head of student administration says yes. The person to give us the data says, oh, I'm skeptical. 9 months later, we finally get the data. Then it's also, do you have the right data? As I mentioned, we have to think about, is the data that's available from these technological systems or sensors, is it the data that actually is going to answer the educational questions we have? Because it's not always that. And I am also open for the fact that we have new kinds of data that maybe we don't know we need, and also can give us some insight into different things as well. So it's going to work both ways. Of course, we have the privacy issues. Here in Europe, we have GDPR we have to follow. We have to have consent if you're over 18. If you're under 18, you have to have parental consent, except in the school municipality, they can collect the data within the municipality for bettering the learning situation for the students. So you have to know the rules and regulations for when you're going to work with the data. Data also has context. As I mentioned in our one project with the peer grade data, we didn't have the context. It makes it much harder to make any real sense out of the data. We also need machine learning algorithms that can explain themselves. In education, we need to know why and be able to explain why we think something about you. And this is a field they are working on this in the AI machine learning communities. And we also have to think about reduction. Can we reduce ourselves to just this data? And I think many of us are different generations than the youth today who are really into the quantified self, and lots of people are doing that. But what does that actually mean in education? I've mentioned these scalability issues about interoperability of data sets. A lot of effort goes into that. I was talking with Martin Eber the other day, and I think he mentioned they've worked 2 years in a project trying to get interoperability, and they haven't managed to do that. The issue of algorithmic transfer, so all the efforts placed in one spot, you may not be able to just take the algorithm and apply it somewhere else as well. The impact is the visualizations, let's say, or dashboards usable? Is it usable? Do people understand it? Is the data literacy issues? Jude Anna, who is a researcher in the US, he was at MIT and has moved to California, and I was at a workshop at LASI last year with him, and they worked with teachers for 1 year to identify 2 questions to ask the students after lessons that would give them the right kind of insight into whether they understood something going on in the lecture and whether she should turn something. So it's very small, little fidgety, and it's very simple visualizations usually that are most effective. Secondly, are the learning analytics used? Even if you can see and see something from, say, a visualization or a dashboard, do you actually use it? Do you use it to change your teaching? And does this learning analytics, this whole field, have any impact at all on learning outcomes? But I mean, that's an education question in itself. How do we measure that and how do we understand that? And then the ethics, because ethics is different. People always group ethics together with privacy and say they have a lawyer involved in these projects looking at the privacy issues, but that's not the same thing as ethics. Remember my university, 73% said yes. What about the 27% who said no? What if we have an adaptive algorithm or we're doing something to give them, help them along the way, and they haven't given us their data? What do we do with those students? Those 27% who aren't going to get the same offer as the other students. So we can think of multiple questions around that. I stole this from Paul Kirchner, who gave a keynote a few years ago at LAC conference, because I really like this to illustrate. If you drop your keys, you're going to look in the light area first. They're most likely outside. So if we can put this into data, we're going to use the data we can get easily, when often it's the data on the outside that we really need in order to work with this data. I think that learning analytics in this phase, those of us and I know a few of us have been around for a long time, it's about managing expectations. Since I've worked in this area of technology-enhanced learning since '85, I've never seen anything go so fast to the leadership of the universities or to institutions. They're really keen on learning analytics. It's going to solve everything. We've heard this all before. Anyone working in ed technology is going to see, but I've never seen it get into the policy levels. My country, they have a policy about learning analytics already, and you're seeing institutions discuss these kinds of issues. So then I feel like, especially my center, when we have also mandate to deal with competence raising around these issues, it's strange. When we got our center, the first one who called me was an ed tech company. And they said, can I come visit you next week? And I said, oh, why? Oh, I want to know how to add learning analytics to my product. I thought, well, I'm a researcher, you know, I don't know how to do that. So it's just the interest is huge, and it probably will take a crash at some point, which is why we made our center about more than learning analytics, actually. Learning analytics is in its infancy. It's exciting and interesting, and hopefully some of you will have learned something today. Thank you.